Welcome to the first session of Rigid Body Mechanics, the introduction. I have a dedicated playlist for circular motion, and I assume that you have already learned them. Circular motion basically was about the kinematics behind the rotational motion, but the dynamics behind that rotational motion is called rigid body mechanics, okay? So let's first learn what the rigid body is. I define the rigid body as an object that it can keep its overall shape, okay, meaning the particles that make the body remain in the similar position relative to and one another. Look at this wheel. Okay, this wheel basically has already trapped some compressed air in, but regardless of maybe that fluid in, basically we consider this object to be almost in a constant and the same shape, ignoring some small deformations. So if I consider a point on this wheel at this point or the other point at this location, they have almost the same position relative to each other. So this object is considered as a rigid body. Or this chair. I know that in the structure of this chair, they may have used some sponge and it is easily deformed. But in general, you consider this shape to be a constant shape. So this is a rigid body. Some liquid is absolutely disregarded here because liquid cannot be a rigid body or maybe just absolutely some amount of gas. So a rigid body basically is not a solid object, but instead we can in general define it as the object that has almost a constant overall shape. Okay? The dynamics behind this rigid body is exactly the topic of discussion for this playlist. To have a warm up, look at this object. This is a wheel rolling down. It's not just sliding down, it's rolling down. So rather than the translational motion it has, it also is considered as something in rotation. So it has also a rotational motion. I have a question. How can we find the kinetic energy or acceleration of this wheel? It is not that easy question, and I don't want to bombard you with a lot of quantities now. Just it's a warm up. How to find the acceleration of this wheel? Okay, let me show you something. You may like it. There is a block, the same mass as the wheel, and let's say the frictional force acting on these two objects is the same. Do they have the same acceleration? What about the kinetic energy? It's not easy to answer, I know. Kinetic energy, let's say EK, is a half of mv squared for this block, you know. What about this wheel? Is it just a half of mv squared? Shouldn't we include another term? Yeah, necessarily we should. But what's that? We will learn it. The next slide is called brotherhood, an expression I invented for this topic. Actually, part by part, it's very interesting to have a brotherhood, a relationship between linear motion and rotational motion. Linear motion, we all learned the linear motion in kinematics playlist. Linear motion is about translation, that the object displaces from point A to the point B. But rotational motion is not about that. It's when the object is orbiting or rotating, okay? There are a lot of interrelations between linear motion and rotational motion. For example, in linear motion, you know what the distance is, the length of the trajectory of the object when it goes from A to B. Instead, in circular motion, we learn that we have angular distance. The angle the object is displaced through when it's rotating, okay? Angular distance. Let's show that angular distance by theta. This is theta, okay? The other is the velocity. You know what the velocity is. Velocity is delta x over delta t in general. The displacement in every second. The brother of the velocity in rotational motion, is angular velocity. We learned it in circular motion, okay? Now I'm gonna have something very interesting, surprising for you. Acceleration. Okay, acceleration in linear motion, is changing velocity in every second, okay? What's the brother of acceleration? It's angular acceleration. The upcoming video will be all focused on angular acceleration. By the way, we know what the mass is in dynamics, okay? What's the brother of the mass in rotational motion? What about the momentum? What about the force? These are the things in the upcoming videos that will be considered in detail. Okay, it was just a warm-up. So let's immediately go to the next video and learn first what the angular acceleration is. Thank you for watching this video and being with me. See you soon.